So for purposes of the recording, I'm just going to mention that we just finished proving that if an object travels at constant speed, its velocity and acceleration vectors are orthogonal. How do you prove that? You write out the three vectors, your position, velocity, acceleration. You write out a function for your speed. You find the derivative of the speed, and because the speed is a constant, then the derivative would be 0. When you divide all the 2's out, what you end up with for the derivative of the speed is the dot product of v and a. Therefore, the dot product equals 0, and the vectors are orthogonal. All right. Okay, so for the next one, prove that an object moving in a straight line at a constant speed has an acceleration of 0. This one actually is a little bit easier. So if you're moving in a straight line, okay. Okay. If you're moving in a straight line, you can just say then that your position vectors are all linear, right? And therefore, your velocity has to be constant, your acceleration has to be 0, and piece of cake. Okay. All right. The last one is the one that I really want to focus on, which is the quarterback of a football team releases a pass at a height of 7 feet above the playing field. So he's like, I don't know. Anyway, and the football is caught by a receiver 30 yards directly downfield at a height of 4 feet. The pass is released at an angle of 35 degrees with the horizontal. So from this, we know two things right off the bat. What two things do we know? We know the initial height, which is 7. We know the initial angle, theta, right, which is 35 degrees. Okay, and of course we know gravity. Okay, so we can fill in those things, but you're still left with an unknown, which is your initial velocity, right? Okay, so how do we solve for the initial velocity? Well, we're given some more information. We're also told that the football is caught 30 yards directly downfield. Is that a horizontal or a vertical distance? It's a horizontal. Now 30 yards is the same as 90 feet, right? And then it's caught at a height of 4 feet. So when my horizontal distance is 90, my vertical distance has to be 4 because they are happening at the same time. So, can't use this, got to come down here. All right. You know what? I'm just going to get rid of all this. Okay. And we'll just talk about it. Okay. So here's my initial position function, right? So that's just plugging in your theta and your initial height and gravity. So we know that when our horizontal component is 90, that our vertical component is 4. So what I did was I treated it as a system and did some substitution. So I set the horizontal equal to 90, solved for t, and then plugged that in for my t's in my vertical position stuff. And then once I got that, I found that my initial velocity was around 54.09. So I treated it as a system, 2 equations, 2 unknowns. And then just did substitution. All right. So the second part of the question was find the maximum height of the ball. So maximum height of the ball, how do you find a maximum height? Set the derivative of the y component equal to 0, right? So anyway, I rewrote my position function. So there's my velocity. Set the y component of the velocity equal to 0. You get that this happens at around 0.969 seconds. You plug that into your y position, and you get that the maximum height of the ball is around 22 feet. Quite a few. I see some boards that got that. So I see a 54 and I see a 22. Well done. Good job, Euler. Yeah. Okay. Oh, did you guys get that too? Wait, let's see. You guys.
We only got 254.
Is your 21.76 because you rounded the 54 to 54? Okay, that's fine. And you rounded also? I see the 54. Oh, I see that there's a 22. Well done. Okay. Guys, well done. So did you all do a system to find the first parts?
Yeah.
Hey. All right. You wrote out what you had. That's good.
Do you get points for writing out what you have?
No. But it's a good start, right? It's always better to do something to get started. All right. And then what is the last thing? Ask. It asks the time the ball's in the air. So you're really just finding the time. So you can either set your y equal to 4 or your x equal to 90 and solve for t. And so it takes around 2 seconds. So yeah, a lot of groups got it. That's good. That's good because that's the kind of question that you might see on your test. Okay. Dora said you can do this. Yes, yes, you can.
I gave up.
Yeah, I know you gave up. But if you did it again, do you think you could do a little bit better?
No.
How about if you did it? If we did more practice?
Yeah, of course.
Okay. All right. Okay. So today, very short lesson. Our only targets are to do a few more PBA related problems and finish a quiz. This is the last lesson for chapter 13.
Oh, okay.
Tomorrow's a review day, right?
Tomorrow's a review day. We have at least one game planned, and then we are going to work on quizzes. Yeah, there's always a game. I have either a Quizlet or a Kahoot for every single unit.
What is it for this one?
Surprise us.
I think it's a Quizlet, but I'm not positive. I'll have to look. I haven't looked. Okay. And then Friday is your what? Big quiz. Friday's your big quiz. All right. Okay. So 3 more problems. Number 3 is just seeing if you remember stuff of old.
If I get sick on Friday, can I take my big quiz on Monday? Projections.
Why would you get sick on Friday?
I don't know. I have a really good feeling sick.
Really? Yes, if you are sick on Friday, you can take the big quiz on Monday, but then you'll miss us going over the big quiz. Yeah. All right. Shh, quiet down, please. A projectile is fired from ground level at an angle of 8 degrees with the horizontal. Find the minimum velocity necessary if the projectile is to have a range of 50 meters. All right, so that's the first one. That's one I want you to really focus on. Part number 2, prove that if r dot r is a constant, then r and r prime are orthogonal, very similar to what we did in the warm-up. And then number 3 is just kind of a blast from the past to see if you remember projections. Now, the reason, I'm going to pause this for a minute. The reason that So the first problem, projectile fired from ground level at an angle of 8 degrees with the horizontal, find the minimum velocity necessary if the projectile is to have a range of 50 meters. So in the context of this problem, the range, the 50 meters, that's your horizontal position you want to end at, and your vertical position would be 0 because you're just going to land on the ground. So, all right, so we know that our theta is 8. We know that our initial height is 0, starting from the ground, and that's really all we know besides gravity, which is 9.8, right? Okay, so we plug those things in. There's my initial setup, and we've got 2 unknowns. Well, really, t is your input variable, but v sub 0 is an unknown, right? But we do know that when the horizontal position is 50, the vertical position is 0. So we can write two equations for our two unknowns. So personally what I do when I set my horizontal position equal to 50, I solve it for t, and then I plug that into my vertical, setting that equal to 0. And then after you do a little number crunching, you get that v sub 0 is around 42 meters per second. Is that okay? Did you have a question? No? I can't tell. Colin, did you get it? Yeah? Okay. Wait, Jack looks befuddled.
How do you know it's seconds?
Only because of the gravitational constant that you used. Right? Yeah, you don't really know. They don't tell you time, but because they only tell you 50 meters, but because you're using 9.8, which is in meters per second squared, it's got to be seconds. All right, good. Any other questions on this one? Not bad? Okay. Prove that if r dot r equals a constant, then r and r prime are orthogonal. All right, so there's my r. R dot r equals a constant. This is a lot like the warm-up. Equals a constant. All right, so you take, it's that same little trick, right? So you take the derivative and you set the derivative equal to 0 because the derivative of a constant is 0. Hey, look at that. But what is this? Once you divide out the 2, hey, it's r dot r prime, right? So it's just that little trick, kind of fun. This must equal 0. Done. No, I don't think so. Okay. And then the last one is just remembering the formula for a projection. So anyway, that's what I got. I got 32/69 times negative 274. There's really no surprises. Okay. Yes.
Are we gonna have to like write out proofs like that on the test?
All right. That's it as far as what I have for this unit, or this section. Now, wait. Just settle. Okay. Before we move on, do you want another? There's going to be some projectile motion in your quiz in the next two quizzes that you're about to do. But if you want the section that we're not doing, which actually, I don't know why it's called 13.5. I think it's because it was 12.5b and then I changed it. The section that we're not doing has a really good warm-up, which is similar to one of your quiz problems. Do you want to try it or do you want to just try it on the quiz? You want to try it right now? Okay, so let me try it on the quiz.
To judge versus all
All in favor of the quiz, say aye. Aye. Majority is aye.
Let's go.
Just give the people the quiz right now.
How about you pass on the quiz and then if you want to do the quiz, you
Alright,
can
how about
do it.
that?
You want to do that?
How about we just talk through this for a minute? Is that okay? Okay. All right, because it's kind of fun, and I hate not doing it, right? So a bomber is flying horizontally at an altitude of 3,200 feet with a velocity of 400 feet per second when it releases a bomb. Okay. A projectile, look at how fun this is. A projectile is launched 5 seconds later from a cannon at a site facing the bomber and 5,000 feet from the point beneath the original position of the bomber. If the projectile is to intercept the bomb at an altitude of 1,600 feet, determine the initial speed and angle of inclination of the projectile. Okay, how fun is this one, right? 0. So here's what we've got. We have two things going on at the same time. So I don't know if I have any pictures on here. Let's draw a quick picture. Okay. All right, so we have a plane. Okay, and so we've got, the plane is flying this way, so we have a bomb.
You just change the bomber to like Santa Claus.
My bomb's gonna look like a fish. Okay,
The
so
board is right there.
So what happens? Okay, so what happens is the bomb is gonna start by kind of going forward, right, and then it's gonna fall to the ground. Okay, all right, because it's gonna start in the same direction that the plane is traveling, right? Okay, so so let's think about what we know about the bomb. The bomb. What's the initial height?
3,200.
3,200 feet, right? Do we know the initial velocity?
Yeah.
What would that be? 400 feet per second. Do we know the initial angle? Initial angle is 0. All right. So we know pretty much everything we need to know about the bomb, right? Okay. So now over here. So if this is our initial point, and this is where I wanted to make sure you understood this, right? So this distance right here is 3,200. So if this is the initial point that is below the bomber, then a distance of 5,000 feet away. So this is a distance of 5,000, right? Okay. So a distance of 5,000 feet away, we have a cannon. Okay, I don't know how to draw a cannon. Okay, and so we have a projectile, and we want the projectile to somehow like explode, like kill the bomb, right? Okay. Okay. All right. So and we want that spot, this spot right here, to be 1,600 feet in the air. Okay. All right. Determine the initial speed. So we need, for the projectile, we need the initial velocity, and we need the initial angle of inclination. We know that the initial height is 0, right? All right. Do you want to take a stab at it?
No.
Yes.
Can we just do it on the quiz?
Well, the one on the quiz isn't this complicated.
Okay, so let's do the one on the quiz.
Take a minute and just see if you can set some equations up. So, plugging in, we've got our position function for the bomb, because we know that our initial height is 3,200, our initial velocity is 400, and our initial angle is 0. So we end up with a pretty easy position function. So setting your height equal to 1,600, you get a time of 10, which is kind of nice. So then that means if you plug in the 10, then you know the horizontal position of the bomb is going to be 4,000. So the position of the bomb is 4,000 for your horizontal, 1,600 for the vertical. What you want then for the position of the projectile is the horizontal position needs to be 1,000. And the vertical position 1,600 because the projectile started 5,000 feet away, right? So, okay. We also know that this has to happen at t equals 5 because this is going to be at t equals 10. The projectile is released 5 seconds later. So there's our position function for our projectile. Okay. All right. So we want the projectile at t equals 5 to be 1,600. So setting your x component equal to 1,000, I solved for v sub 0, and then plugged that into my y component, set that equal to 1,600, and then solved for theta, which was around 63 degrees. Is that what you got? Yeah. Okay. And then your initial velocity, you just plug the 63 degrees in, and you get an initial velocity of around 447 feet per second. It was fun. pod. How much fun is that? Right?
Really sad.
Okay.
Just that we wanted to do it on the quiz.
Here endeth this lesson. I'm going to stop the recording.
Record them.